In our notes for today, we're going to just continue on with the solving equations sheet. And remember, eventually in a week or so, we're going to have kind of a larger assessment over all of these solving of equations. And so this is where we left off, guys, is we were doing rational equations. Rational because they are fractions, right? Okay, and then equations because they have an equal sign. And our method there was we multiply everything by the common denominator, cancel, and go from there. All right, so today we are going to do start off by solving literal equations. And so what that means is it just means it has a bunch of variables, okay? So solving literal equations. For example, and you'll see these equations from time to time. Let's say we had something like 4h over a minus 3 is equal to d. And this could mean like anything, like h and a and d could mean anything. It's just some sort of relation. But it right now is solved for d. And let's say we wanted to solve for a. So it's just using our regular rules of algebra, but I got to get this guy by itself. Okay, and on top, by the way. So first thing I'm going to do is I'm going to try and get this alone by moving the 3 over. So I'll add 3 to both sides. So we got 4h over a is equal to d plus 3. All right, now having a in the denominator, that's a bit of a problem. I got to get it up into the numerator. So what we do and how we do that is we multiply both sides by a. And so what happens is on the left side, the a's cancel. So I have 4h is equal to, and I'm going to write that a out in front, but it really doesn't matter. It just looks a little bit more like what you'd see in a nice math book. And so now to solve for a, I'm going to divide both sides by d plus 3. So a is equal to 4h divided by d plus 3. And that's our answer. So sometimes I get the question, well, do you have to solve it? It is solved. It's solved for a. It's solved for a in terms of h and d, but it is solved for a. All right, so I'll do another literal equation, but again, it just has a bunch of variables, and I'm really, quite honestly, guys, making just some of these variables up because they could be any kind of relation. Let's say we had big A little b squared plus, how about big Q squared is equal to L. And let's solve for B. When we do that, we're going to, because it's a b squared, I can already see we're going to have to take a square root. So let's say that we're not going to do, so no plus or minus. I'll explain that in just a minute. When we take the square to both sides, we're not going to do the plus or minus thing. We're just going to stick with the principal root or the positive root. We want to solve this for b. So first move that q squared over. So I get big A b squared is equal to L minus q squared divided by a. So I get b squared is equal to L minus q squared over a. And take the square root of both sides. So b is equal to the square root of, and that's where the plus or minus, we don't need to do that out front, okay? So the square root of L minus q squared all over a, and there it is solved for b. in terms of L, Q, and A. All right, so those are literal equations, okay? So next, I'm going to solve some exponential equations. And we've done these before, but I just want to bring it back because it obviously fits in our solving equations part. Solve exponential equations. And we'll do a couple of these. Now, an exponential equation means that the variable is an exponent. So this would be an example of an exponential equation. Let's say we had 15 is equal to 1.09 to the x minus 8 power. All right, that is an exponential equation. 1.09 to some power, that's ugly. Okay, so I don't know how to do that in my head. But what I can do is I can put this into log form. So remember when we put it into log form that this is going to become the base of the log. So this would be written as log base 1.09 of 15 is equal to x minus 8. Okay. Now, what you're really doing, and you guys don't need to write this down, but you know, this little trick, and that's kind of what it is a shortcut of writing that into log form. We're really doing an algebraic operation. I mean, if we had 15 equals 1.09 to the x minus 8, okay, so like I just rewrote that. What we're really doing is taking the log of both sides. We're taking log base 1.09 of both sides. And remember, log and exponential functions are inverses. So those two sides cancel, those two operations cancel out, and the right side is just x minus 8. And the left side is log of 1.09 of 15, okay, which is the same thing we wrote. So in putting it in log form, you're really just performing an operation. It's just a shortcut in doing so. So I just wanted to point that out because we are solving equations. You know, we're kind of just following our same rules of algebra and doing that. But we got to keep going here. We still have to solve it. Now, as an exact answer, we could say x is equal to log base 1.09 of 15 and minus 8. That would be an exact answer. I'm going to use my calculator, though, to find an approximate. So notice I put that 15 in parentheses because this is one chunk, okay? So I have log base 1.09 of 15 minus 8. So here we go. Log base 1.09 of 15 and then minus 8. And I have to get my approximate answer, and I get approximately 23.424. So I'll round it to the nearest tenth. Oh, thank you. See, you guys at home let me off there. It is plus 8, not minus 8. I made a mistake here, right? When we move this guy over, this should be a plus 8. All right, so that's, of course, going to change my answer. I'm going to go back, and I'm going to do this. but I'm going to make that plus 8 and get my approximation. So we now have 39.4. So 16 bigger than our other answer, obviously, right? So X is approximately 39.4. Thank you very much for catching my bad algebra there. All right, let's do another one. All right, let's say we have log base 6 of 9x. Whoop, I'm sorry. Scratch that, guys. I was reading the wrong one here. 86 is equal to 9 times 5 to the x plus 41. All right, we're trying to solve for x again. Got to get the x by itself. So the first thing I'm going to do is subtract the 41 over. So 86 minus 41, we get what? 45, right? 45 equals 9 times 5 to the x. Now, do not do this. Don't multiply those, okay? Because ordered operations say we don't do that. We would do, the exponent first. So we're trying to get this thing by itself. We're going to divide by 9 on both sides. So that's going to be 5 equals 5 to the x. And so then x, of course, is 1 because 5 to the first is equal to 5. All right, so we did some exponential functions and we had to use some logs to do that. And now we're going to go the other way and solve a couple of log equations. Okay, and those usually go hand in hand. So that's why I'm going to do that next here. So solve log equations. So let's start with log base 5 of 6x plus log base 5 of 4 is equal to 3. So that is one ugly log equation, right? It has logs in it. It has an equal sign. It's a log equation. So remember our rules of logs. We can combine these into a single log, and the addition means we're going to multiply those two things. Addition becomes multiplication when we're condensing those. So we have log base 5 of 6x times 4, which is 24x. All right, so that's our first step. I did a couple things there. I multiplied 6x times 4 and put it all into one chunk. But now I have to change this into exponential form. So remember, the 5 moves over and the 3 moves up. So I get 24x is equal to 5 to the third, which everybody now knows is 125 because we've been working on those powers, right? And so x is 125 over 24. That's our answer.
Mr. O'Connor,
Yeah.
do we leave it as a fraction?
Yeah, you can leave it as a fraction or a decimal. Either way is fine. Good question. And you can do an improper fraction like this, or you can always write it as a mixed number. However you want to leave it is perfect. It doesn't matter. And also, just to point out, this idea of going from log form to exponential form, we are, again, just following rules of algebra. What we're really doing, if we have log base 5 of 24x is equal to 3, here's what we're really doing is to get rid of log base 5, it's an equation, so I'm taking 5 to the power of both sides, which is perfectly fine to do. It's an equation. As long as I do the same thing to one side, I do the same thing to the other. Well, those two things cancel out, and the left side becomes 24x equals 5 to the third. That's what we got. Okay, so we're really just following rules of algebra, but writing it in another form is just kind of a shortcut of doing that algebra. All right, we got one more for you guys. So in our next one, it'll be a log equation again. So let's say we have log base 6 of 9x minus log base 6 of 4 is equal to 2. So remember in our last one, the addition was multiplication when I combine them. The subtraction is going to be division. So this can be written the left side as log base 6 of 9x over 4, 9x divided by 4, is equal to 2. Now we write that in exponential form. So 6 moves over and the 2 moves up. I get 9x over 4 is equal to 6 squared. Of course, is 36. And so x is going to be 36 times that reciprocal. So I'll do that, 4/9. And so using a little canceling, we can see that x is equal to 16. All right, so we had a couple good questions. Any other questions?